Properties of determinants. So, whenever we deal with matrix and try to find out the determinant, there are certain properties that these determinant or the matrix will follow. First thing is, the first property is that if you change or interchange the rows and columns, that is, if you take the transpose of the matrix, that is, if A is your matrix and change it to transpose rows and column, you just interchange this row to this column, this row to this column. Actually, it's just equivalent to the transpose. So this row, this column, the row and column interchange or column or row interchange will not change the final result. The determinant will remain same. Now the second property is if any two rows or columns of the determinant we interchange, then the final determinant will have a negative sign, will have a minus sign. Okay. What does it mean is that you have a determinant, then how it will be negative when you change or change the position of two rows or two columns. That is, this is one row, okay, R1. So we have changed the position here. Now it has become row 2, and the row 2, this row has become the first row. So now you have changed the position. Now when you change the position, the determinant will simply, if the determinant is D, the resultant determinant of the interchange row or column will be negative D. One, if it is 5, it will be negative 5. So how do we change? See, this is R2, we interchange R2 with R1. If all the elements of a row is multiplied by some non-zero number k or lambda, that is a scalar, then the value of the new determinant will simply be k times the value of the original determinant. Okay, when you multiply this whole row is multiplied by k. So you just can take k common and you say that this is nothing but the actual determinant multiplied by k. So I'm just, it can be column also. If I multiply this by say m, one column by m, so it is simply equal to m into the determinant. Determinant is simply of a1 b1 c1, a2 b2 c2, a3 b3 c3, right? Okay. Let me tell you an example here. For example, you have 2, 4, 8. The other elements can be anything. You understand by this. I can write 2 as 2 into 1, 4 as 2 into 2, 8 as 2 into 4. Okay. Now you have 2 common in all these. So what you can do is you can take 2 common outside. This is equivalent to k or m, which I am talking about. You can take 2 outside. It will be 1, 2, 4. Inside this, it can be anything. But what it is that this is a determinant, and simply this is k into d, and what is k here? It is 2. There is also a possibility to understand this, that you can have m multiplied inside and 1 by m outside, because ultimately 1 by m multiplied inside is going to cancel this out. Or you can say m can be taken out and m by m will be 1. This is the same thing. So single row or single column multiplied by some scalar, it can be taken out and you say it is multiplied by the whole determinant. Very important property of the determinant is that if you have a summation, the second, you see here, first column has a summation and second and third column remains the same. So you can write this matrix as 2 matrix as an addition. That is first 3, that is a1 b1 c1 plus the x y z along with this b1 and c1 column. That is, we can combine these two. The right hand side matrix can be added and can be equated to the left hand side. This is one and the same thing, right? The value of the determinant is unchanged if any row or any column is multiplied by any number, any way you want. It doesn't matter. It's up to you to make the determinant simpler. For example, if I have this column a1, a2, a3, I have taken first column. Now in some my thought I devised, I have to multiply this second column with m and then add it to the first column. So let us multiply each element of the second column by m and add it. So mb1 plus mb2 plus mb3. Now I think, okay, more good option will be to subtract the n multiple of third column. So minus nc1 minus nc2 minus nc3. Whatever you want to do, it has to be applied to whole column or whole row. The determinant will not change. The value will not change, right? So this row, if I take this will be simply a3, a3, a3 everywhere. If any two rows of a determinant, they are same, they are identical, they are similar, then the determinant is going to be 0. For example, in this determinant, you see, I'll show you the actual property also for that. There is a byproduct of this property also. See, if you change the row 1, saying that row 1 should be replaced by row 1 minus row 3. Since row 1 and row 3 are same, a1 minus a1 is 0, b1 minus b1 is 0, and c1 minus c1 is 0. So I have just changed the row 1, so other rows will remain same. This all remains same. Okay. Now what are you going to get from here? If each element of a row or a column of a determinant is 0, then it is going to be 0. How it is going to be 0? See, these two properties are almost equivalent. Let us open this determinant by first row. So 0 into something will come. I'm not writing. Second is minus 0 into something will come. And the third plus 0 into something will come. Now you see here, I don't have to write anything inside because there is already 0 multiple. So everything will be 0. So if the row or a column of any matrix is 0, the determinant will be 0. This is equivalent to saying that if the two rows or two columns are equal, then we say that the determinant is 0. Okay. Now we have a diagonal matrix. What is a diagonal matrix? The element in the diagonal will have some value. The other values will always 0. So a11, a22, a33, a and n will be some value, others will be 0 when I is not equal to j. So this is a diagonal matrix. For example, I am writing 2, 3, 2 and 0, 0, 0, 0. This is a diagonal matrix. So what will be the result of determinant? You can directly write 2 multiplied by 3 multiplied by 2. It will simply be 12.